Question 2 from the 2018 free response part of the exam deals with a particle moving on the x-axis, and they're giving you the velocity functions. And this is a calculator active problem, so you can use your graphing calculator to do any derivatives and integrals and all that. And actually, the more complex functions like this one, they would expect you to use a calculator to find any derivatives or integrals. Okay. All right. So part A, and they give you the particle is at position x equals -5 at t equals 0. And they want to find, for part A, find the acceleration of the particle at time t equals 3. So let's go to our paper and we'll do the correct write-up on that. So the acceleration is the derivative of the velocity. So we would want to write v prime of 3, which is equivalent to a of 3, which will be about, okay, and we're going to put this into our graphing calculator. Okay, so I'm going to go to my graphing calculator and put this in. So I want to press y equals, and I want to put my velocity function in for y1. Okay, so I want to press alpha x to get the fraction bar, and then 10, and then sine, and then 0.4 t squared, which in this case t will be x, so 0.4 x squared. Then close the parenthesis. And then the denominator is t squared minus t. So x squared minus x, and then plus 3. Okay, and then what we'll do back on our home screen, okay, we'll press alpha window, because we want the derivative, okay, so number 3, and take the derivative with respect to x of our velocity function, which was stored in y1, and we want to do this at 3. Okay, so we get an answer of -2.118. Let's go back and let's record that on our paper. So we record this is -2.118. Okay, and then let's go to part B. So for part B, we want to find the position of the particle at time t equals 3. We know the position at t equals 0, it's -5, right? So we want to integrate this from 0 to 3, and we want to integrate the velocity function because that would give us the change in position, okay, or displacement, okay? So let's go to our paper and we'll write that up, and then we'll go to our graphing calculator. Okay, so for part B, if we integrate from 0 to 3 of v of t dt, I know this is going to be equivalent to x of 3, so the position on the x-axis at time 3 minus the position at time 0, okay? And if I move this over, right, I would have x of 0 plus the integral from 0 to 3 v of t dt. So we would have x of 3 is equal to x of 0 plus the integral from 0 to 3 v of t dt. And we know x of 0 from our paper that it is -5, right? So we would have x of 3 is equal to -5 plus the integral from 0 to 3 v of t dt. And we'll do this integral. We'll take -5 and we'll add the integral to it, and we'll have the position at time t equals 3. Because this is the change in position, okay? All right? So x of 3 is equal to, and we're going to go to our calculator and put that in. So we want to type in -5 and then plus, and then alpha window for the integration, number 4. And we want to integrate from 0 to 3. And our velocity function was stored as y1, so we want to press alpha trace y1 x and press enter, and we get -1.7602, so that would just be -1.760 or -1.76, and that's our answer to this. So I'm going to go back and record. Now, technically, I shouldn't be putting in equals here, okay? I should actually be putting, so I'm going to change it, okay? They're not going to take off if you put it in equals, okay? But x of 3 is about -1.760. Okay, or -1.76 would be good too, because that'd be 3 decimal places. Okay, so that's the answer to part B. So for number 2C, okay, they want us to evaluate 0 to 3.5 v of t dt, and also evaluate 0 to 3.5 of the absolute value of v of t dt, and then interpret the meaning of each integral in the context of the problem, okay? So let's first evaluate these two integrals, okay? Let's do that first. And we'll go to our calculator, and actually, let's write it on our paper. So let's go to our paper, we'll write these two down, and then we'll go to our calculator. Okay, so what we want to do is we want to evaluate the integral from 0 to 3.5 v of t dt, and we want to know what that is. And then we also want to integrate 0 to 3.5 the absolute value of v of t dt. Now the absolute value of velocity is really speed, right? So this is integrating speed. So this one's going to give us total distance between 0 and 3.5, and this one's going to give us the displacement or the change in position, okay? So that's going to go into the interpretation of this, okay? So I'm going to go to my graphic calculator. I'm going to do both of these, okay? All right, so back to the graphing calculator. So we want to integrate, so we're going to press alpha window and number 4, and we're going to integrate from 0 to 3.5, and v of t, which we stored as y, so alpha trace number 1, and then dx, okay, and then 2.844, okay, and this is the change in position, which we call displacement when it's a particle moving, and we're using velocity and all that, okay. Now we want to do the absolute value of this, okay. So again, we're going to integrate, so alpha window function integrate, so 0 to 3.5. But now we want to enter, before we put y1, we want to do the absolute value. So that's alpha window, and number 1 is the absolute value function, and then the absolute value of the velocity, which is stored in y1, and then dx. Okay, and we get 3.737, okay? So let's go back to our paper and record these two values. So the integral from 0 to 3.5 of v of t dt, from the calculator, we got negative, or not negative, 2.844. So we'll record 2.844. You could also truncate, so it'd be 2.843. And then this one, okay, was 3.737. Okay, and then now we have to go into the meaning of these, okay? So what is this one, okay? So this is the change in position, which we call displacement, okay, in physics. So the integral from 0 to 3.5 v of t dt is the displacement Now, instead of saying displacement, you could also say change in position, okay? Is the displacement of the particle between t equals 0 and t equals 3.5, okay? And I don't think they gave us units on this. No, they didn't. Okay, so just, you can't put units on this time, okay? You don't know if it's seconds or minutes, okay? Now, how about the absolute value ones? Okay, so what's this one? Okay, so 0 to 3.5, absolute value of v of t dt. Okay, so when we take the absolute value, that takes anything that's below the x-axis on the velocity and flip it up, right? So it's above the x-axis. So all of these function values have to be positive, right? So if we integrate, we accumulate distance, right? But in this case, all the velocities are going to be positive. So all our function heights are going to be positive, which is not going to give us the net change, but the total distance traveled, okay? So the integral from 0 to 3.5 of the absolute value of v of t dt is the total distance traveled by the particle between, and you got to add this part, between t equals 0 and t equals 3.5. Okay. Now you could write this as an integral, because when we say between, you could also, say this between, in this one and the previous one, you could say something like this: 0 less than or equal to t, which is less than or equal to 3.5. That's between 0 and 3.5 still. Okay. So I just realized you didn't see this. Okay. Let me take this off my pad. Okay. Sorry. So integral from 0 to 3.5 of absolute value of v of t dt is the total distance traveled by the particle between t equals 0 and t equals 3.5. So this between t equals 0 and t equals 3.5 could be written as an inequality like this. Okay, for this one and for this one. Okay, it wouldn't matter either way you write it, as long as it's on this time interval. Okay, that you're writing that. So you can write it in words, or you could write it as inequality. You could even write it in interval notation. Okay, so it'd be bracket 0, comma 3.5 bracket. Okay, sorry, I didn't realize I was writing and you guys couldn't see it. Okay, all right, so let's go to part D now. Okay, so for part D, they're asking you a second particle moves along the x-axis with position given by this second function, right? So this is the position function, right? And it's equal to t squared minus t, and it's for 0 less than or equal to t, less than or equal to 3.5. So it only works for those between that time interval. Okay, at what time t are the two particles moving with the same velocity? Okay, so the velocities have to be the same. That would mean for this function right here, I'd have to find the velocity function for that particle for v sub 2 of t. Okay, and then set it equal to this velocity function and see where they're equal. But I only want to look on a limited region, right? I only want to look between 0 and 3.5 to see if this is happening. Okay. All right, so let's go to our paper. We'll write this up formally, and then we'll go to our graphing calculator to solve this. Okay. Okay, so I know that x sub 2 of t, from what I read, was t squared minus t. Okay, so that would mean x prime sub 2 of t, which is also equivalent to v sub 2. Hold on, let me get some more ink. V sub 2, I had to change colors too. V sub 2 of t would be equal to 2t minus 1. Okay, all right, now I know this is v sub 2 of t, right? I want to know where these velocities are the same. So you need to write this, because you're going to solve this. Okay, you're going to have v of t, which is the original velocity of the original particle. Okay, and we want to know when this is equal to v sub 2 of t, right? Okay, so we have the velocity function. This velocity function we already have stored in our calculator, y1. We're going to put this one in for y2. Okay, and we're going to put in 2t minus 1. Okay, and then we're going to look between 0 and 3.5 and see where they intersect, and that will give me the time or times in which the velocities are equivalent, okay, or the same. All right, let's go to our graphing calculator now. So from our graphing calculator, we want to go back to y equals and go down here to y2, and we want to type in the velocity function for that second particle, right? V sub 2, okay? And we're going to write 2x minus 1. Okay, and our window, we want to only look between 0 and 3.5. So 0 to 3.5. I would keep the x scale as 1. Y min to y max, who knows what this should be. Okay, so let's just keep it at negative 10 to 10. And then let's graph it and see what happens. Okay, so it looks like it's only going to happen right here. Okay, I'm gonna do a zoom box. So I'm gonna show you something. You wouldn't necessarily have to do this on this problem, okay? But I just want to show you a feature that you might want to use. Okay, we're gonna zoom box, and just to get a good window. Okay, I'm gonna press enter there. I want to go above where they intersect at least, right, to the maximum. Actually, let's just go up a little bit higher. A little too high. Press and then go to the right, and we can adjust this a little bit if we want to. I'm going to come down a little bit, and then I'm going to press enter. I just want to show you this, okay? You wouldn't have to do this. It's right here though, right? That's when the two velocities are the same, okay? So the red one is the velocity of particle 2, and the blue one's the velocity of the first particle, okay? So let's go to second, calc, and then number 5, intersect, and then enter, and guess just be close to it, and it's 1.57, and that 5 right in the fourth position, right, will cause this 0 to become a 1. So 1.571, okay? So let's go to our paper and let's record this value. So solving this equation that we have right here, t would be approximately 1.571. Okay, so the two particles are moving with the same velocity at time t equals 1.571, okay? The two particles have the same velocity at t is approximately 1.571, okay? And this whole problem was a particle moving on a line problem because it was moving on the x-axis, so that's just back and forth, right, on one line. Okay, so they're going to ask you a problem like this, okay? They may not, okay, for AB, they may not ask us the total distance because that's something that's going to come up in the unit after the exam that we're going to do, okay? So you probably won't see that, but you should know that the integral from 0 to 3.5 v of t is the displacement, okay? Because we've talked about that one, okay? And that's in earlier units. Okay, let's go to the next problem, guys. From the 2018 free response part of the exam, question number 5, they're giving you a function, e to the x is equal to cosine x, and they're asking you a variety of different questions using that. So let's just go ahead and do part A. Find the average rate of change of f on the interval 0 less than or equal to x less than or equal to pi. Okay, that's just slope between 0 and pi. Okay, so let's go ahead and do that on our paper. So this would be f of pi minus f of 0 over pi minus 0, okay? So f of x was e to the x cosine x. So this would be e to the pi cosine of pi, and then minus e to the 0 cosine of 0 all over pi minus 0, that'd be pi. Okay, so this would be e to the pi, and then cosine of pi is negative 1. So this would be negative e to the pi. So negative e to the pi. And this would be e to the 0, which would be 1. And then cosine of 0 is 1. So this would be minus 1 over pi. Okay? And I would just leave it like that, okay? All right, let's go to part B. So part B is, what is the slope of the line tangent to the graph of f at x equals 3 pi over 2? Okay, so to find the slope of the line tangent, we've got to find the derivative and then put 3 pi over 2 into that derivative, okay? So we'll do that next. So we know that f of x is equal to e to the x cosine of x, and we've got to find the derivative of that. So that'd be f prime of x. And this is a product, so we're going to have to use a product rule, okay? So the derivative of e to the x is e to the x times cosine of x, and then plus e to the x times the derivative of cosine x, which is negative sine x. Okay, so then that would mean f prime of x is equal to e to the x cosine x. I'm just going to clean this up a little bit. And this would be minus e to the x sine x. And we want to find this at 3 pi over 2. So this would be f prime at 3 pi over 2. So this would be e to the 3 pi over 2 cosine of 3 pi over 2 minus e to the 3 pi over 2 power, and then sine of 3 pi over 2. Now cosine of 3 pi over 2 would be 0. Okay, so this would be equal to e to the 3 pi over 2 times 0. Sine of 3 pi over 2 is negative 1, so minus e to the 3 pi over 2 times negative 1. Okay, so this is going to be 0. So this would equal, okay, e to the 3 pi over 2. And that would be your answer, okay? All right, that's it for part B. Let's go to part C. So for part C, they say find the absolute minimum value of f on the interval 0 to 2 pi, and then justify your answer, okay? So we have a closed interval, right? Okay, and so we gotta find the um, the critical points for f, okay? Which means we gotta find where the derivative is either 0 or undefined, okay? And then check our endpoints, okay? And whichever one's the smallest, that's gonna be the absolute minimum, okay? So we'll do that next. So from part B, we know that f prime of x is equal to e to the x cosine x minus e to the x sine x. Okay, so e to the x is a continuous function. There's no breaks. Cosine x, same thing. And so when we go to subtract and so e to the x and sine x is also continuous functions. And when you multiply them, you get a continuous function. So there's no discontinuities, okay? So there's never where this is going to be undefined, okay? But it could be 0, okay? So we're going to set it equal to 0, and then this would be e to the x and cosine x minus e to the x sine of x. We would want to factor out an e to the x here. So 0 is equal to e to the x. And then we'd have cosine of x minus sine of x. So the only way for this to be 0 is if one of these is 0, okay? So we have e to the x would be equal to 0, or cosine x minus sine of x is equal to 0, okay? And then here we could natural log both sides, but if we natural log both sides, okay, we're gonna get the natural log of 0 on this side, right? And so natural log of 0 doesn't exist, right? It's undefined. So that means there's no solution to this one. Okay, so there's no x value that will make this one true. Now on this one, if we add sine x, right, that would give us cosine x is equal to sine x. And this is a situation that doesn't happen very often, but the problem is we have two different trig functions, right? But we're dealing with sine and cosine. So a way to deal with this is you can divide on both sides of this by cosine of x. Now what happens when we divide this side by cosine x? We would get 1, and this side would be sine x over cosine of x. And then we can use a trig identity that sine x over cosine x is tan x. So really 1 is equal to tan x, or tan x is equal to 1. Okay, now we can solve it because now it's just one trig function, okay? Whereas before we couldn't because it was two different trig functions. We can figure out where tan x is 1, okay? So the ratio would be 1 over 1. That happens when x and y are the same sign. So that can happen in this first quadrant because x is 1, y is 1, and that would mean this would have to be the square root of 2. This can also happen when this ratio is -1 over -1, and that would happen down here in the third quadrant. So -1, -1, and this would be the square root of 2. Then this reference angle would be pi over 4 for both triangles. But the angle of rotation, because we're looking between 0 and 2 pi, so the solutions to this would be pi over 4. That's this one, okay? And 5 pi over 4. Now 5 pi over 4 comes from, this is 4 pi over 4 right here, and we need to go one more pi over 4, okay? Okay, so there's 4 candidates for which one could be the absolute minimum. It could be 0, it could be pi over 4, it could be 5 pi over 4, or it could be 2 pi, okay? So we got to find f of 0, right? And that would be e to the 0 cosine of 0. Okay, so e to the 0 is 1. Cosine of 0 is 1. So this is 1 times 1, which is 1. Okay, so that could be the absolute minimum. Okay, then let's do f of pi over 4. Okay, so that'd be e to the pi over 4 cosine of pi over 4. And cosine of pi over 4, and this would be e to the pi over 4 times, and then cosine of pi over 4 would be 1 over the square root of 2, or square root of 2 over 2. So this would be e to the pi over 4 square root of 2 over 2. And we'll come back and talk about what's the size of that. Okay, then we need to do f of 5 pi over 4. And that would be e to the 5 pi over 4 cosine of 5 pi over 4. Okay, so this would be cosine of 5 pi over 4. We can actually use this, right? It'd be negative 1 over the square root of 2, or negative square root of 2 over 2. So e to the 5 pi over 4 times negative square root of 2 over 2. So this would be negative e to the 5 pi over 4 square root of 2 over 2. Now there's going to be, okay, without a calculator, this is going to be hard to do, like which one's the smallest, right? But there is a way, because this one's negative and these two are both positive, and they're asking for the absolute minimum. So right now it has to be this one, right? And unless we go through, and I just realized you guys didn't see it. Ah, dang it. Okay, I'll let you look at that for a minute. Okay, so now let's look at f of 2 pi. Sorry, I should have been looking at my screen instead of looking at the paper. Okay, f of 2 pi, which would be e to the 2 pi cosine of 2 pi. Okay, so cosine of 2 pi is negative 1. Oh, I'm sorry. Cosine of 2 pi would be 1, right? Because you were back to where we started with. So this would be just e to the 2 pi times 1, which would be e to the 2 pi. So that's like, you don't have to figure out the decimal equivalent of this, right? You can tell which one's the smallest because this is the only one that's negative. So they write problems like this, like they would not expect you to do the decimal equivalent of either one of these, okay? Okay, so we know the absolute minimum is this value, and it's happening at 5 pi over 4, okay? So f of x has an absolute minimum of negative e to the 5 pi over 4 square root of 2 over 2 at x is equal to 5 pi over 4. And you can't see it again. Dang it. Sorry, guys. Okay, so that's it. F of x has an absolute minimum of negative e to the 5 pi over 4 square root of 2 over 2 at x equals 5 pi over 4. Okay, and that's part C. Okay, so let's go on to part. So for part D, it says let g be the differentiable function such that g of pi over 2 is equal to 0. The graph of g prime, the derivative of g, is shown below. So this is the graph of g prime. Find the value of the limit as x approaches pi over 2 of f of x over g of x, or state that it does not exist. Okay, and then we need to justify our answer. Okay, so if you look at this, okay, we're to take the limit as x approaches pi over 2, you want to see what happens if we try to do direct substitution, right? What happens when we put f of pi over 2 over g of pi over 2? Okay, well, we know right here g of pi over 2 is 0, right? So this is going to make this denominator 0. Okay, but how about f of pi over 2? Well, it's also going to make it become 0 because cosine of pi over 2 is 0, and it doesn't matter what e to the power is, it's going to come out to be 0. So we have 0 over 0, right? So this is L'Hopital's rule. They're testing you on L'Hopital's, right, on this one, okay? All right, so let's go to this one, and we'll answer part D. So they're asking for the limit as x approaches pi over 2 of f of x over g of x. Okay, so to use L'Hopital's, you must break this up into and write two limit statements. Okay, so if we take the limit as x approaches pi over 2 of f of x, okay, that's, if we try to do direct substitution, that would give us e to the pi over 2 cosine of pi over 2. Cosine of pi over 2 is 0. So 0 times e to the pi over 2 is going to give you 0. And then we also need to do the limit as x approaches pi over 2 of g of x. And we know because the function is 0, okay, and it's differentiable, which means it's continuous, okay, that would also equal 0. Okay, so this is because of this, because of these two statements, right? This one and this one, we can use L'Hopital's rule, okay? So this is equivalent to the limit as x approaches pi over 2 of f prime of x over g prime of x, okay? So trying to do direct substitution, this would give us, for the derivative, it would give us, because we already figured out derivative, right, in part B and in part C, okay? This would give us e to the pi over 2 cosine of pi over 2 minus e to the pi over 2 sine of pi over 2 all over, okay, if we take the limit as x approaches pi over 2 of g prime, okay, they gave us the graph of g prime, right? So you go back and look at this, what happens for g prime as you approach pi over 2? Well, as you approach pi over 2, both sides are approaching the same thing. It's 2, right? Okay, so this would be over 2. Well, what do we know about cosine of pi over 2? Again, that's going to be 0, right? So this is going to be 0. Sine of pi over 2, okay, is 1. So this becomes negative e to the pi over 2 over 2. And that's the limit, okay? It's negative e to the pi over 2 over 2. And they're testing you explicitly on, do you know L'Hopital's rule and when to use it, okay? So that's it for today. I just want you to do 2018 question number 2, and I think it's 2. Yeah, 2 and number 5, okay?